science. The facts are with science. Science is real.
Dear listeners of WHCR 90.3 FM, the voice of Harlem, welcome to today's program. This is Angelo Lampousis, your host from the Department of Earth and Atmospheric Sciences here at City College of New York, broadcasting live with the help of Aaron Slodovnik, who is doing a great job in the sound engineering as every week, and our group of honor students from the Macaulay Honors Program here at City College, who are situated very nicely in the green room, and we have them here with us. We're very pleased to welcome for the first time in our program Dr. George Arnold. He's the National Coordinator for the Smart Grid Interoperability Program. We will explain everything very soon for the National Institute of Standards and Technology. Dr. Arnold, welcome to today's program.
Oh, thank you very much. It's a pleasure to be here.
And we've had the opportunity to highlight a few aspects of your work with NIST. I think just to help a little bit our listeners to position or put some context in our discussion, would you mind sharing some of the activities of NIST in general, the National Institute of Standards and Technology, so we have a better idea?
Sure. Well, NIST has been around since 1901. We were established by Congress, and NIST's basic mission is to support the innovation process in the United States with a focus on what we call measurement science and standards. Basically anything that one needs to measure for either industry or scientific research. NIST probably has one of the world's leading experts developing better ways, scientific approaches to measurement. Anything from time to various physical measurements to even your cholesterol readings in your lab are traceable to standard reference materials produced by NIST. We also are responsible for coordinating the federal government's activities in the area of standards, and we have about 2,000 scientists and engineers. About 400 of them are engaged in over 1,000 committees in organizations that develop standards.
And we should, I think, mention the fact that some of these scientists, we're not talking about just any scientists. There are several Nobel Prize laureates and so on and so forth, right?
Yes, indeed. It's an amazing place.
So moving on a little bit to this, the history of the electric grid. Some of us, we have, or maybe all of us actually, there's no generation that has not grew up with the electricity. But living in New York and doing this program live in New York, I think we should pay a little bit of tribute to something like the Edison Pearl Street Station, for example. I know you've used a few of these images in your presentation. Would you mind sharing some?
Sure. Well, the first electric generating station in the United States was built by Thomas Edison on Pearl Street in Lower Manhattan. And some of the old images of this station, it looks remarkably like coal plants that you see today. The only major difference is that it was DC power instead of AC power, although maybe we'll even be moving back to DC power someday. But the basic architecture of the electric grid that we depend on today, it's much the same as it was in Thomas Edison's day. Basically, burning fossil fuel, moving that power through one-way flow to end users, and you have to produce as much electricity as you need to meet peak demand. Mm-hmm. There have been a lot of innovations in the system, but the basic operating principle is really not changed that much in over 100 years. It's amazing.
If you just tuned in, you are listening to WHCR 90.3 FM, the voice of Harlem. We're talking to Dr. George Arnold, who is visiting City College today. His duty location is actually Washington, so we're very privileged that he's with us today. And I think it's a good opportunity for us to consider what goes into an electric grid. I know we get a feel for it every month, those of us who are paying for it, right, through our electric bill. But it is now high time across the US and the world, perhaps, of this same grid to become, I don't know, I have heard different terms. Maybe you can help us. I have heard smart, I have heard smarter, or perhaps you can give us a little bit of the specifics of this process of transitioning to something newer.
Sure. Well, the term smart grid refers to the fact that intelligence in the way of information technology, automated controls, computer optimization is being applied to the electric grid in much the same way that this sort of automation was applied to the telephone system about 30 years ago. And it's kind of amazing that it's 30 years later, and we're just now getting around to applying the same concepts in the electric grid. As I mentioned earlier, the grid, has to be engineered to meet peak demand. And if you think about different times of the day and days of the seasons of the year, in a hot summer day, a lot more electricity is used than on let's say a fall evening when you don't have heat or air conditioning and businesses are not operating. And so during those non-peak times, much of the capacity in terms of generation and transmission are just sitting there unutilized. And this is very inefficient. And in the using computer-based automation, measurement, sensors, controls, you have the ability to perhaps shift some of the demand on the system so that it occurs during these non-peak hours. As we introduce more renewable energy into the grid, like wind and solar, where you can't really control the output, it's dependent on nature. It's possible to adjust the demand so that it more closely tracks the available generation. So these are some of the basic concepts in the smart grid that will make it much more efficient than the grid we have today.
And I think this is the term that I started off with from your title, as the national coordinator of the smart grid interoperability. Obviously, there are different operating systems, and I guess it's part of your job to coordinate how these different operating systems may talk to each other in a way, if you could. Is that...
Exactly. Well, if you think about the computer industry, if you go back 30 years or so, systems were built with proprietary architectures, right? You had IBM, you had in those days digital equipment, you even had Xerox was making computers in those days, and they all used proprietary operating systems, proprietary protocols, and it was very difficult to make systems that mixed and matched equipment from different vendors. That's the way the grid is today, that you have suppliers to the electric utilities who have provided proprietary interfaces, and so it's very difficult to introduce innovation into the grid because you're basically locked into a single supplier. With the introducing intelligence into the grid and the automation, information technology, this has to be based on standardized interfaces to get this interoperability so that you can have equipment supplied by different manufacturers that work together to introduce automation and controls on an end-to-end basis.
I was wondering, listening to this particular topic, it comes to mind, and I know you and I have been at the same conference last June in Washington at the Library of Congress, focusing on the role of standardization in strategy, innovation, and entrepreneurship. So it seems that standards in this industry as well, they're interwoven in the way they're supporting innovation. And I was wondering, what's your take on this aspect from your experience dealing with these processes?
Well, if you think about the changes in the way we communicate and deal with information over the last 20 or 30 years, it has just been remarkable. The internet is based on a standard set of protocols that allow many different types of devices to interoperate. It provides standard services that you can implement new applications very easily and deploy them widely at very low cost. This is all made possible through standardizing interfaces. So this is sort of the next wave of innovation in the electric grid, is standardizing interfaces. So for example, if you get a new appliance, think of an electric dryer, for example. In addition to the electrical interface, it will also have an information interface so that it can communicate with the grid. It can be informed what price electricity is at a particular time of the day, and if you just want to set it to like an economy mode, it will automatically determine the best time of day to run to dry your clothes, so they'll be ready at 5 o'clock for your evening out, and cost you the least money by running it when electricity prices are low.
Very good. We will be going soon in a break, and before we do that, we can squeeze maybe another question that I had in mind. Particularly the module that you developed through NIST, and I was very intrigued the first time I've heard about it, because in a way you defied Google in doing that, and there was at some point, I understand, the so-called Google Power Meter, and apparently NIST did a little bit better than, or a lot better than this. So if you would, excuse me, share that as well.
Yeah, well, that was a neat story. So, in the U.S. we have about 3,000 electric utilities that are all independent of one another, and Google had this great notion that they would be able to get access to the data coming out of electricity meters, smart meters, right, and be able to show you a web page where you could compare your energy usage against your neighbors or similar households, and offer tips to save your energy bill. Well, so Google went around to the different utilities and made an offer that if they would just provide the data in a particular format that Google was specifying, they would make this capability available. And they weren't getting a whole lot of interest, because the utilities figured, well, this week Google is here, next week Microsoft is going to come in with a different data format, and so on, and they just, didn't want to develop 6 different interfaces. Mm-hmm. So the White House actually got involved and had a better idea, which is, let's come up with a national standard for a data interface for your electric usage information. And so NIST, working with the North American Energy Standards Board and a large number of stakeholders, developed a standard data format, and this has now been adopted by the industry, and there are now, by the end of this year, there will be about 36 million consumers. That's 20% of the U.S. households that will have electronic access to their energy usage information as a result of having this standard available.
Excellent. We will be going to a short break. And when we come back, we will have questions by our honor students from the Green Room. You're listening to the program Innovation Unedited through WHCR 90.3 FM. Stay tuned.
I'm an engineer, respect my mind. I made the refrigerator to make your eyes freeze better. I'm an engineer, respect my mind. I made the airplane, car, motorcycle. I'm an engineer, respect my mind. So bow down when you see me downtown. I'm an engineer.
Don't touch that dial. Keep it locked on WHCR 90.3 FM, the voice of Harlem. Status rule, okay. Status rule, okay. Status rule, okay. Status rule, okay. Stand up, stand up, stand up, stand up, stand up.
Dear listeners of WHCR 90.3 FM, the voice of Harlem, welcome back. This is Angelo Lampous, your host from the Department of Earth and Atmospheric Science at City College of New York, talking to Dr. George Arlund, the National Coordinator for the Smart Grid Interoperability Project for the National Institute of Standards and Technology. We're moving on to the second half of our program, the last part of our program, and we have with us one of our proud honor students. Isabel is with us today to help us deliver the questions to our guest. So, Isabel, please.
The first question is from Dashel. It is, are there specific areas in this country where the telecommunications network is not fully developed, or is the network fairly uniform throughout the country?
Well, by telecommunications, we're talking about the electric grid, so perhaps the question has to do with telecommunications to support the electric grid. And there are certain areas of the country that I would say are leading, but it has more to do with the regulators and their policies, whether they're encouraging investments in new technology. So you look at states like California, which have been very progressive and really leading the charge. Texas is another example. New York has done a lot in the transmission part of the grid. So you definitely find certain areas of the country being much more advanced than others.
Okay, our second question is from Matthew. How do the electric companies react to the standardization of the electric grid, and do they welcome the change?
Well, the electric companies certainly welcome it because it reduces their cost. It makes them not locked into specific vendors because they can kind of mix and match. Initially in this program, we found that some of the suppliers were not that enthusiastic about it, especially if their business model was based on proprietary equipment and locking in their electric utility customers. But that's pretty much changed, and I would say the industry has now gotten the picture that everybody is better off by allowing innovation to occur and building these systems on interoperable interfaces.
The next question is actually my question, and it's a bit of a different direction. But you told us earlier that you are looking into solar energy for your home. So do you have any other energy-saving suggestions for those of us who do have to pay energy bills?
Whoa, that's a good question. Well, there's a lot of information available on the Department of Energy's website, but one really simple thing is changing out your light bulbs to either compact fluorescent or even better LED light bulbs. They're expensive, but they save a lot of energy, like 1/10 or 1/5 of the energy usage of incandescent lights. If you live in an area where electric utilities are allowed to provide time of use or variable pricing, just checking to see what's the best time of day to run your appliances is a way of saving money.
All right, thank you. Our fourth question is from Damien. Would the standardization of the electric grid mean that every electric supplier in the U.S. would use the same standard to provide electricity?
Well, most of the standards that we're talking about here have to do with the information that's needed to control, monitor and optimize the operation of the grid. So the actual physical electric system, it's 120 volt AC 60 hertz. That hasn't changed. What is changing is the fact that you now have information in addition to the electricity that interact both between the components within the grid as well as with the users of the electric grid.
All right. The next question is from Brianna. The grid systems in the United States are divided by region. Is there any particular area that you feel uses techniques that are more effective, for instance, in preventing/containing blackouts?
Well, the western part of the country, with so-called Western Interconnect, has been sort of leading in the deployment of what are called networked phaser measurement units. These are devices that take real-time, 160 or 120 times a second snapshots of frequency and other parameters of the electric grid, and give you wide area situational awareness and the ability to respond quickly when things go out of balance. These devices are actually being deployed throughout the United States in the entire transmission grid in the U.S. But I would say the western part of the country is maybe a little bit ahead of other parts of the country in terms of actually networking and using these sensors in the most effective way. Okay,
well, this is the last question by Tiffany. How will the trillions of dollars it will cost to regenerate and improve the country's electric system be paid for?
Well, it's very, very interesting. The Electric Power Research Institute, which is kind of a think tank that supports the electric utility industry, did an economic study. And what they concluded was that it would cost about $400 billion over a 20-year period to introduce the kind of automation I was talking about, but that the economic benefits that result from that $400 billion investment are between $1.5 and $2 trillion. Just coincidentally, the cost of replacing the aging assets in the grid over 20 years is estimated to be about $1.5 to $2 trillion. So that $400 billion investment basically recovers enough payback to pay for all of the required investment in infrastructure.
I would like to jump in. Thank you so much, Isabel. Great work. And I would like to take the opportunity to acknowledge NIST in general, since we have adopted a few standards here in the curriculum at the Department of Earth and Atmospheric Sciences. We have had the opportunity to work with several members of NIST. We have interviewed in the past Clara Asmail, the director at the time of the Small Business Innovation Research Program for NIST, and also we're working on with Eric Poskar on different committees, including the American National Standards Institute Committee on Education. And in fact, by coincidence, although Dr. Arnold and I have scheduled this program today since last summer, by coincidence, the Macaulay Honors College was awarded from NIST a standard-setting simulation exercise that is happening tomorrow at the Macaulay Honors College. And this was a very nice introduction for all of us to the events that will take place locally here in New York tomorrow morning. This has been the program Innovation Unedited through WHCR 90.3 FM, the voice of Harlem. This is Angelo Lampucci, your host. Isabel shared the questions of the students. Thank you, Isabel, again. And most importantly, we thank our guest today, Dr. George Arnold from NIST. Thank you so much for being with us today.
Thank you. It was a great pleasure.
And the eggs that I eat, I got text through my head, airborne through my feet, shade, stadium, the radium, E&D square, kick out of the palladium. Just think that I can't. It's the sound of science, the sound of science.
Don't touch that dial. Keep it locked on WHCR 90.3 FM, the voice of Harlem.